You've no doubt heard of Pythagoras before. You know how the area of a square is just one side times another side, right? If the length of a side was a, then we could say the area was a times a, or a squared. If we took three squares and arranged them like this, so they formed a triangle-shaped hole in the middle, we could see something called the Pythagoras Theorem in action. The theorem is a simple equation. A squared plus b squared equals c squared, as in the area of square A plus the area of square B equals the area of square C. That's pretty interesting, huh? With a bit of algebraic manipulation, we can make the equation tell us more. Take the square root of both sides. We now have an equation for C, which is the length of the longest side of the right-angled triangle, which we call the hypotenuse. Rearranging the equation for A or B will give us the lengths of the other sides. If we know the length of two sides of a right-angled triangle, we can always find out the third side using this equation. These right-angled triangles have another property: trigonometric ratios. This is a beautiful thing. Let's set up our right-angled triangle like this, with some angle at the bottom left represented by the symbol theta. There are three ratios, and they're used to find the lengths of the sides. The first is sine. It's the ratio of the side opposite the angle over the hypotenuse. The second is cosine. It's the ratio of the side adjacent, or next to the angle, over the hypotenuse. And the third is tangent, which is the ratio of the length of the opposite side over the adjacent side. For short, we call these three ratios sine, cos, and tan. And we remember the ratios with SOHCAHTOA. Let's say we don't know the length of the opposite side. If we know the length of the hypotenuse, we can use the sine ratio. Using algebra to rearrange the equation, we can see that the hypotenuse times the sine of the angle will give the length of the opposite side. Similarly, the hypotenuse times the cosine of the angle will give you the length of the adjacent side. If this angle is unknown, but we know two of the sides, then again, with some algebra, we can find the angle. If we know the lengths of the opposite side and the hypotenuse, then we can take the inverse sine of the ratio, leaving us with the angle. See how this is just simple algebra? The only thing new to learn here is the ratio of sine, and that the inverse sine is the opposite operator of sine. The same way addition is the opposite of subtraction, or division is the opposite of multiplication. What if you only know the adjacent and hypotenuse sides? Same again. The ratio using those two sides is the cosine ratio. So we write the cosine of the angle is equal to the adjacent side over the hypotenuse. We perform the inverse cosine on both sides of the equation, and voila, we get our angle. If you only knew the opposite and adjacent sides, you'd use the tangent ratio in the exact same way. Trigonometry requires some practice, but it's well worth it. Try out some of the examples and use your calculator to find some of the values. Remember, the Pythagoras theorem is a squared plus b squared equals c squared, where c is the length of the hypotenuse. Use SOHCAHTOA, where sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Sine, cos, and tan will find you the length of a side. Inverse sine, cos, and tan will find you the angle.